Hi, my name is Mike Simonelli, a member of the IST 440 capstone team, along with my teammates Abram Selleck, Maranth Kumpf, and Gregory Tapia. Today, Abram and I will demonstrate a system that law enforcement and legal personnel can use to take a handwritten cipher and, using digital technology, decipher it to render clear text. Welcome to today's demonstration of the capstone system. The capstone system is a three-step process that allows you to take the handwritten cipher, prepare it, and get it ready for digitization, and then ultimately decipher it. I'll be demonstrating the manual process and the use of MATLAB, and then hand it over to Abram to show how ZK Decrypto can be used to decode the cipher into clear text. The manual part of the process involves assuring the quality of the handwritten cipher in preparation for creating a digital replica that a user can then upload and use in MATLAB to take advantage of that tool's optical character recognition capability. We create that digital replica using either a scanner or a camera. In this demo, we'll take a snapshot of the cipher, and we'll save that as a .png file, which is one of the many formats that is supported by MATLAB. A user would then upload that .png to a folder that's in MATLAB's path to begin the OCR process. We upload our cipher.png file to the server where we have our instance of MATLAB, and then we run the Capstone Digitize module. So let's walk through this quickly. We take advantage of MATLAB's ability to read image files, in this case the cipher.png file. Once we have that file read in, we can then use MATLAB's optical character recognition capability to attempt to recognize characters within that image file. Here we see that OCR results.text is actually a class, and one of the properties of that class is the text, and that text will be any of the text that the character recognition capability has indeed recognized. We open up a MATLAB figure window, and then we're going to do two things. We're going to show the cipher image that's found in cipher.png, and alongside of that, for comparison, we're also going to open a small window that has the recognized text that resulted as from the OCR character scan. We'll open up a file. In this case, it's a file called cipher.txt, which is found in a MATLAB folder that's residing on my desktop. And into that folder, we're going to print the recognized text, which again is the result of the OCR scan. And then we'll close that file. Let's run the Capstone Digitize module. And you'll notice here that we've opened up the figure 1. And what you see in the center is the cipher.png image, and alongside of that, the results of the OCR scan, the OCR results.txt. In MATLAB, the folder, we should see a file that's called cipher.txt. And if we open that up, we see that indeed MATLAB has obliged us and written out to that file the OCR results.txt as well. This cipher.txt file now can be used as input to ZK Decrypto to use to attempt to decipher into clear text. So to recap, we started with a handwritten text, took a photograph of that, saved it as a .png, uploaded that to our Windows server, ran the MATLAB Digitize module against that, read in the cipher.png, and then used MATLAB's optical character recognition capability to render text into this cipher.txt file, which can now be used as input into ZK Decrypto for deciphering into clear text. Here I have a terminal window open on a MacBook Pro, and I'm running a command line version of ZK Decrypto. What I'm going to do here is activate ZK Decrypto and attempt to decipher the cipher.txt file that we output back in MATLAB. So I'm going to call up the current directory, and I'm going to call ZK Decrypto Lite, and I'm going to then pass that decipher.txt file. We're not going to stick around for the entire run of this, as it takes 2 minutes, but we'll see how far we get in this first pass. So 2 minutes has elapsed, and here is the result from ZK Decrypto. And at first glance, it doesn't look as if it's done much of anything, but let's take a closer look. I'm going to copy this, and I'm going to paste it into a word processor. And I'm going to show you how we can take this first pass and make some sense out of it. Now, I know what the clear text says, so if you start to parse, you'll see that there are various words that are actually beginning to show themselves inside of that long, unparsable, seemingly unparsable string of characters that was returned. What the clear text actually says is this is an example of a cipher that has been created using a simple transposition technique where a letter is shifted left or right a certain number of places in the alphabet, period. This is the standard capstone proof of concept text, period. Now, this is only the first round of ZK Decrypto attempts at deciphering. There are various parameters that we can pass to ZK Decrypto that allow it to hone in on a better deciphering of the cipher. We can have it run longer than the 2 minutes, and it actually gets better over time. We can also give it a target score. The actual Zodiac ciphers, the 340 cipher, was cracked by ZK Decrypto using a solution score of 4,400. It runs a very long time to achieve that score, and a simple cipher like this one would easily be cracked by setting the score to 4,400. And you can also give it the number of iterations. As well, there is a GUI version of ZK Decrypto that allows for the insertion of words and various homonym pairs, and allows you to look at letter frequencies and the like, and a good crypto geek can certainly crack many of the codes that are out there using these tools. I hope you enjoyed today's demonstration. We showed you how you prep from a handwritten cipher, take that through MATLAB, and eventually feed the output to ZK Decrypto to begin to decipher into clear text.